All right, let's jump right in. Today, we're going to pull back the curtain on something that happens every time you use an app, something that decides if it feels super fast or painfully slow. We're talking about how a database actually finds your information.
You know the feeling, right? You tap a button, and you get the dreaded spinning wheel. You wait, and you wait. But what's really happening? Often, it's not a bug. It's just a really slow conversation happening in the background with a database.
So, section 1, the pain of slow data. Where does this slowness actually come from? Well, a lot of the time, it boils down to a pretty fundamental communication gap.
Think about it like this. When you're using a language like Java, you're being imperative. You give the computer step-by-step instructions on how to do something. But with SQL, the language of databases, you're being declarative. You just say, hey, get me all my active customers. You tell it what you want, but you leave the how completely up to the database.
And that leaves the database with this huge responsibility, right? If you're not telling it how to get the data, it has to figure out the absolute best path all on its own. So how on earth does it make that choice? To answer that, let's dive into section 2. This is where our main character comes into the picture. Let's imagine that every database has its own built-in genius trip planner. Its one and only job is to map out the most efficient journey for your data requests. Now, in the tech world, this trip planner has a real name, the Query Optimizer. And hey, this isn't just us making up an analogy. Database experts at Oracle talk about it this way too. It's basically an internal TripAdvisor that, the second you ask for data, is already calculating the fastest, most efficient route to go get. So what's its number one goal? Well, the optimizer looks at all the possible ways to get your data. And as the official Oracle SQL tuning guide says, its mission is crystal clear. Find the plan with the lowest cost. But wait, cost here doesn't mean money. It's not even necessarily just about time. It's an internal score, a number that represents how much work a certain path will take. You know, things like how many times it has to read from the disk, how much CPU power it's going to burn, and how much memory it needs. A lower cost means a faster, more efficient trip. All right, section 3, choosing the best route. So the optimizer has all these potential paths, and it has to pick the cheapest one. Let's look at how it actually decides. It follows a pretty logical 4-step process. First, it gets your travel request. That's your SQL query. Step 2, it brainstorms all the possible routes, which are technically called execution plans. Then, and this part is absolutely crucial, it checks the latest traffic reports and road conditions, which we call optimizer statistics. And finally, after weighing all the options, it picks the route with the lowest calculated cost. And believe me, the cost difference between these routes can be just massive. You've got the full table scan. That's the slow, scenic route, where it literally looks at every single piece of data. Its cost? Through the roof. But then you have an index scan. That's the superhighway. It goes straight to the data it needs, and boom, the cost is tiny in comparison.
Okay, so that's the big question, isn't it? The planner sees these options, the highway and the winding back road. But how does it know which is which before it even sends the data out on its journey? How does it make that cost estimate so well?
Well, it all comes down to the information it has on hand. The best trip planner in the world is useless if its maps are old or it doesn't know about traffic jams. So this traffic data is what we call optimizer statistics. The database is constantly keeping notes, like how many rows are in a table? Is this a tiny village or a massive city? How many unique values are in a column? Are we dealing with 1,000 different street names or just Main Street and First Avenue? It even looks at how the data is spread out. Is traffic flowing evenly or is everyone stuck on one particular road? And here's the most important takeaway for sure. These statistics have to be fresh. If your data changes a bunch but you don't update the stats, the optimizer is basically navigating with a map from 10 years ago. And honestly, this is the root cause of so many performance problems. It's often not about needing faster hardware. It's about the planner having bad information. Now, what about those shortcuts? In the database world, a shortcut is called an index, and the book analogy is absolutely perfect. Instead of reading a whole book from cover to cover to find one thing, that's our full table scan, you just flip to the index in the back, find your topic, and go straight to the right page. That's exactly what an index lets a database do. And it gets even cooler, because there are different kinds of shortcuts. A clustered index is kind of like a dictionary. The data itself, the words, are physically stored in alphabetical order. So if you're looking for the word optimize, you just go right to the O section. But a non-clustered index is more like the index at the back of a textbook. It'll tell you that optimize is on page 25, but the actual information isn't in the index itself, it's just pointing you to where it lives. Okay, section 5, making the planner smarter. So this planner is already pretty smart, but can we make it even smarter? Oh, yeah. Turns out it can learn. So what if your GPS could look at that awful trip you took yesterday, the one with all the traffic, and then give you solid advice on how to do it better next time? Well, that's pretty much what tools like Oracle's SQL Tuning Advisor do.
It's like a personal coach for the optimizer. It'll scan for those out-of-date maps, finding stale statistics. It'll recommend building new highways by suggesting new indexes. It'll even look at your original travel request and say, hey, maybe if you asked for it this way, it would be faster. And probably the most powerful thing it does is create a SQL profile. Think of it like a sticky note on a map with special instructions, correcting the planner's bad assumptions so it makes a smarter choice every single time.
All right, section 6, why fast queries matter. We've met the planner, we've seen its maps, and we've even given it a coach. So let's bring this all home and talk about why any of this actually matters to you. So how much of a difference does all this really make? A staggering one. Get this. Here's a mind-blowing fact from Oracle. For some types of queries, like in big data analytics, being almost perfectly accurate is good enough. Well, these approximate queries can be over 97% accurate while running orders of magnitude faster. That just shows the incredible speed you can unlock when the planner has what it needs.
At the end of the day, this all comes back to that feeling we talked about at the start. A smart, low-cost query plan means a snappy app. It means happy users. It means systems that aren't wasting energy and resources. It all starts with helping that internal trip planner find the best route. So the next time an app feels sluggish and you're just staring at that spinning wheel, maybe you'll think a little differently. It might not just be a slow app. Maybe, just maybe, its database is lost on a scenic back road because it desperately needs a better trip planner. Thanks for tuning in.